I am going to teach you about how to use sheet metal in Creo Parametric 3.0. Before starting this, I want to illustrate why this is necessary to have a special workbench of Creo Parametric instead of part module. If we talk about the part module, uh, just think we are going to use part module only for the designing of sheet metal. What things we will have to keep in mind? See here, just think this is our length of our sheet. I am giving it 200 mm. Okay, and I will give it some thickness. Just think it is 2 mm the sheet of ours. Just take 10 mm, no problem. Okay, this is our first sheet. Let me change it to 2 mm only. Where is 2 mm? This 2 mm. Now thing is that if we are going to create another sheet on this face and going to this sheet, like this, and I am going to make it 50 mm wall, and okay, give it the thickness of 2 mm. Something wrong, wait a sec. So no problem, we will use another method, extrude into front, and we are going to extrude a rectangle instead of a line. Okay, just think we have to make this wall. This is 50 mm and this is 150 mm, no problem. Okay, thing is that we know that is 2 mm wall, and it's this side, either side you want to make it, no problem. Okay, thing is that here you will see a corner, but in the case of sheet metal there is no corner. Whenever we try to bend a sheet into multiple side walls or any other shapes, then in the sheet metal they forms a curve shape, a radius, not a corner. And in order to design a sheet metal, we will have to keep in mind several things like corner relief, bend reliefs, and etc. To overcome that, there is a special module in Creo Parametric part module and sheet metal. Okay, we will select a unit system. Now in our sheet metal, few features are unavailable, and few features are extra, like this sector, and in this sector also, Now we are going to first a planar wall. That means the first sheet we are going to parent sheet we are going to make. Instead of using rectangle, I will make some lines. Before that, I'll make center line. This, keep this first line and just give dimensions 50, and in this case I am going to use a relation. Just think 2 into 25 into pi. Whenever we will try to enter, it will ask that it will make a relation. Yes. Now if we will try to change this value, we will not be able to. Then how we will change it? Just go to tools, relations, and here is your relation we have put it. Okay, if we have to change it to 25 30 mm, automatically it will calculate and change the distance. Now make the rest of the things. And give some equal commands like this, and this will be equal, and so no problem, this and this will also equal. Give it to 100 mm. Now we should take some metal, 200 mm. Okay, and I am going to erase this relation too, and going to make these and this equal. Then to delete equal this and this, no problem. Okay, now we are going to give a thickness. That means our sheet metal will work on this thickness. I am taking it as 2 mm, but in this case 2 mm will be too much, so I will take it 1 mm only. Okay, just this is our thing. Now we have to bend it. Just take bend and put a corner. If we will select a surface, then it will give us 2 selection. For the bend line, it is for the bend line. Now we will have to put some distance like 30 mm, and in this case just 100 mm, no problem, 90 mm. It is bending like this, but we have to bend it totally round, not as this. See our output. Our output is this, but we don't have to make this. And thing I was discussing, see here is a radius. You can also control this radius in several ways. Just I am deleting this, and now again bend. Now this time I will choose a corner, an edge. It will make radius. Now I am putting the radius of 30. Look at this, and I will going to change it like this. Now we had given the radius of a relation of 2 into 30 into pi. That means 30 was the radius of the circle. Now we made it round on the basis of 30 mm radius. We see the output. Our thing is like this, but look at this. Just think, we don't have this, don't have to round this section. Then we should take transition. Transition does that, just we will discuss it later. And I am taking is 20. Oh, sorry. Bend, redefinition, transition, add transition, sketch, bring to front, and now we will draw 2 lines. This is transition line. That means first it will deform in this case, this region. Then from this region to this region, it will try to make it straight, and then this region will not deform. We will look in this. Just take it as 20 mm, and this is 50 mm. Enter. Okay. Look at the result. This region is completely deformed by the round bend section, but in this section there is no any change. And this section, this region is like loft command, that from round to straight line it is deformation. Okay, this is our output. And further, if we have to add a flat flange or any other, just think I am using planar only in this region and front we are taking it as a reference. Okay, and now no problem, just take a center line. This is a symmetry relation. Okay, no problem. Normal from this to this 10 mm, and this height will be 25 mm, no problem. 20 mm, and this section will be 30 mm. And one thing more, this section, what dimensions we had put here, we don't recognize that, no problem. Just mirror it. Before mirroring it, we will select all these sections and mirror it around this. Okay, and now put the dimension from this to this, and this will also 10 mm. Okay, now our sketch is fully defined, but thing is that it is not closed. Now it is closed. Okay, change it to 10 to 20 mm, 10 to 15 mm, and 15 mm too. Okay, and change it to 50 mm, no problem. And one thing more, we will take it 25 mm, 20 mm, 15 mm, and vertical relation with this and this. Okay, leave it, no problem. This is the relation, this is the thing which is between us, this and this. Now okay, and okay, we made another wall. Look at this, it automatically determines the previous sheet of metal, and see here, there is no any dimension we have allowed. The main thickness we had provided in the starting of the planar surface in the sheet metal, it took that dimension in this itself. References, it merge to model. That means it will make an identical sheet. In order do not merge, then it will make a surface or any other, but merge it. Okay, this is the thing. Now if we have to make a flat flange, then we will discuss it as another example. And look at this, we will just make some here is not defined, some flushed, and take this. Okay, same command, flushed. Now some things we can modify it here, length of this flush, and it is also denoted by hem in some softwares. This is the distance from the edge, we can modify it too. And okay, look at the result. But thing is that if we are going to unbent it or flat pattern, if we are saying watching the flat pattern, then what will be the thing here, it will ask for the bend line, bend allowance. That means if we will bend our sheet metal, then it will cause some error at the edge of that, from the corner of the bend. We will modify that too. We will delete this flat pattern. So this is our thing. Before that, I am going to discuss some features like flat pattern and other sheet metal parts and take a planar surface. Here in this case I am taking a rectangle, not necessary dimensions, but we will take some like 400, no problem, and okay, 1 mm thickness, and this is our flat sheet, primary sheet. Now what is the difference between flat and flange? Take first, just we will zoom at the corner so that we will get a better idea. This is our edge, shading with edges. This is our edge, and I am going to hide all these surfaces, planes. Now I am going to take this edge. Look what will happen. This edge will be deformed as the radius, and our outcome will delete this edge. Now if we will choose the another edge, upper edge, then it will go downward. Okay. This is the thing, if we have to use it upward or downward, we will have to be clear on the selection. And few things like this is the angle 90 degree, you can change this like this. This is the clearance from the edge, this you can see it here, and I am putting it 10 mm and 10 mm, but thing is that it go outwards. If we will have to make it inward, then we will put is -10 and -10. Another thing, it is height. Whatever height we want to give, we will modify. As I mentioned that we can change this radius. Here it is modified. We at this time it is assuming the thickness as the radius. That means we made a 3 mm of the sheet, then this radius will be 3 mm. If we want to modify double of the thickness, then double of the thickness. Either we will take 10 mm thickness, it will make 10 mm thickness. But thing is that during manufacturing process, is it easy to bend it like this? There is no clearance between this wall and this wall. Just okay. There is no clearance between this plane and this plane. It will surely make some error, and so for manufacturability we will edge. This is the shape we had provided here. We can also edit it like 100 mm like this, or in sketch model. If you want to do this, you can do this in sketch model. No need to use rectangular. We can also make, 1 second, let's see, yes, rectangular, let's make shape, sketch, and if you are going to make an arc, you can do this easily, or any other thing you want to do, you can make it. Now again sketch, going to front, and I am going to make it as a construction line. I am going to make some spline instead of, just to show you that how it works. But thing is that it should be tangent for the better output. It's not necessary, but for the better output in manufacturing product, we have to keep it tangentially. This is okay. But thing is that what we were discussing about the offset. No, first relief. The clearance between this. There are two types of allowance. First is corner relief. Okay. And continue. Just first I will around. Look at this section. Around. It is side 2. Look at this. If we have no relief, rip means that it will directly tear it with no clearance. Stretch, that means there will be no cut, it will bend and stretch the material. Rectangular, a rectangular clearance. Around, just it will put around here, around. Or rip is the default action. Rip means just cut through, nothing else. And we can use separately, each side separately. If we don't want to do separately, we will just modify it once and it will happen in both sides. But if we want to modify it different, like here rip and here around, then we will use side one thing, and side 2 like stretch. This is the thing. Now another thing, bend allowance. In sheet metal, if we bend an object, if we bend a sheet and again we flatten it, then the change in length is due to the K factor. That is called bend factor, bend allowance. We will use either K factor, Y factor, or bend table, anything of that. Think is allowance. What is allowance? Sorry, offset. Just we will change relief to side around. Okay, offset we will see, and we will change it to 0, the offset distance. No, this not this distance, shape, and this distance as 0, and this distance as 0, and change it rectangular for the better. What is the use of offset? Just we will deselect it again, and we will see what happens at the sheet. Whenever we select this edge, then it deforms this edge and puts the edge inwards. We can use this edge, we can modify this edge in this section. Offset wall. Automatic means it will reduce this and take it as this wall as a radius. Now change to add to part edge. That means it will not deform the primary sheet, and it will add from the end of that, like this. This sheet is original sheet and it does not deform, but this deforms. Second, by value. If we put some value, it will increase the length of the primary sheet to that length, whatever we want. And from where this distance will be, you can change it here at the bent surface or origin. You can modify it, and the value automatic. Again, one thing is more, like where the radius falls. If we put 10 mm radius, that means which radius will be 10 mm? Inward radius, outward radius, or center radius? That means it shows inward radius. That means if we see inside radius, that will be 10 mm, and if we will see like this outward radius, then outward radius will be 10. And it is a symmetric radius. That means if we will draw a symmetric line between these two surfaces, that will be 10 mm. And I think it is clear to all of you. Okay, this is the thing, is that we can modify the profile of this face in flat, but in case of flange, you can modify the profile of this. In this case, it draws a straight line, but in this case, you can draw different shapes, like this shape. Go to the shape, sketch, bring to front, and instead of making a line, I am making an spline like this. just put it tangentially, because in sheet metal there is no corner. Construction line, tangent this, wait a sec, okay, no problem. First put a line like this, and then we will draw a spline like this. Delete spline, and put it tangent, but keep something in mind that this is an error, so modify it so it cannot cause any error in our case, because thickness of sheet will be also occur in this region. Look at this, we made this section like this, and if you want to modify the radius we can do that, 10 mm. We can also increase it like fillet. Okay, look at our output. There are inbuilt too many surfaces. We selected the upper surface, upper edge. Okay, and if we want to put the some clearance, then it is our clearance. Right click, edit definition, and change this. This is angle. Okay, no problem. Placement, shape, this is our shape, this is I shape, arc shape, S shape, open shape. Look at this, open shape, and flushed, that means it will be stuck, like hem, jog shape, and many more, duck shape, jet shape, all user defined that we made in previous example. This is a deformation of the sketch, and it is a thickness allowance from where length offset. Again we can modify its offset from here, add to part edge, same whatever we did in that case, but length, if we will put it 10 mm here, and blind 10 mm here. Look at this, this is that length, inward and inward, what I was trying to do in this case. It is stuck, no problem. Okay, here it is shown also. It is first length, it is second length. If we will put it 25, and it has a 25, but in the negative value, minus 25, enter, and minus 25, enter. This is our output. And if you want to change the length, this length, it is our output, easy. Okay, now again we will go on our previous metal. Here it is mid, and if we want to use different shapes in this case, we can do that. And instead of making this range, delete, just we will go and change its definition, bring to front. If we don't want to make this as a line, just to make this take it as a mirror about this, and it is symmetric, no problem, and trim this. Mm, or 10 mm, whatever you want you can make it, and it is 100 mm. Okay, you can use this type of a structure. Now you can use flushed at this edge, change length or anything you want to do so. Okay, some extra features are available in engineering section of this sheet metal: rip, form, corner relief, conversion. I will make another video for the conversion and a few more things, but in this case for the overview of sheet metal I will show you some forms, factors, die, punches, etc. Punch form, just select the model, which model, open flat lower form. Now this is your punch. Punch means it will push from the upward to the sheet metal, and the sheet metal deform in another direction, like push. Select this edge, select another edge and give some dimension or placement. Here you will get an output like this. In case of die form, it will first select a die, same die I am taking this, but it will push downward, in the direction of itself. It shows a cavity, it have a cavity, and okay, look at this. In the case of die we put it upward, and in the case of form we put it downward, but the output is same. And sketched form, if we sketch any form like this and give it some distance, change the direction, okay, it will look like this. But if we want to make it open like this, some sections are cut from this, then option exclude surface and select the surface you want to cut. In the previous form we can also change the cut surface. Just go to shape, here options, here is individual surface already selected, it will be cut. But if we want to modify it, we can do that. Just remove it, and just I am selecting this surface only as, look at this output, we deselected that. And if we want to select all of those, just remove it, hold control and start selecting. Whatever surface you will select, after holding control it will remove that surface. This is the thing. Same thing in flatten form. That means ki if you used any form on the surface and deform that plane, but you want to make it as original, then you can use it. And this shows a symbol but doesn't change anymore. That's why this is done for the purpose of the designing before the die or punch used. Another thing I want to mention, if we want to use the flat pattern instead, if we use unbent, it will also make a unbent pattern, a flat pattern. But thing is that it deforms the model permanently, and if we want to bend it again, then it will be used for unbent. Okay. But thing is bend again, we will have to bend it again for the our main output. But in case of flat pattern, just I'm deleting that flat pattern, it does the temporary effect. That means it shows us that the feature is being bent. I am suppressing this model because it makes our drawing too complicated. This was our flange, we will suppress it. Okay, no problem. Now we have to see the difference between flat pattern and unbent. If we want to cut here, we want a cut here, just I am going to extrude and selecting a surface, but it automatically bend again. But in case of can see flat pattern we will going to delete it, and but in case of unbent feature, okay, and now I have to extrude in the surface, it doesn't deform again because that was temporarily effect, it is permanent effect. We got to and bend back. If we have to put this type of cuts in our sheet metal, that we have to use unbent feature, then we will use the feature we want to do so, and then bend back. But in case of flat pattern, it show preview of the of our workpiece. And there is another feature in the creo parametric 3.0 that it will show dynamic pattern. Now whatever thing we will do in this section, just unbend, okay, and another extrude cut I am going to make here, and a circular cut I am going to make, and okay, just watch here, our preview automatically updates. And if we want to save this pattern, we can create an instance, and if we will go to the drawing section, we will get that pattern again. If you want to see it again, this is our thing. And if you want to show the dimensions, etc., here you will get the dimensions, the final of our workpiece. So we can decide our designing is okay about our workpiece requirement or not. Okay, this is the basic tutorial I had made for to understand the parametric sheet metal module. But I will demonstrate in another video about the conversion feature and some offset feature and fill feature, basic features which I have left out. Thank you, thanks for watching.